Hey everybody, so we're going to learn another way to do a proof today. Today we're going to learn a little bit about indirect proofs as well as inequalities in one triangles. So by the end of today you're going to be able to prove statements using this indirect method. You're also going to understand what role inequalities play in triangles. So let's look at this statement first. It says, at first, I assumed that we are having hamburgers because today is Tuesday, and Tuesday is usually hamburger day. There's always ketchup on the table when we have hamburgers, so I looked for the ketchup, but I didn't see any. So the question is, what can I conclude? Well, if it's Tuesday, I typically have hamburgers. And if we're having hamburgers, I typically see ketchup on the table. If I don't see ketchup on the table, then we're not having hamburgers. That makes the most sense. So, there we go. No ketchup. No hamburgers. Now, is that a guaranteed? No, we know that a lot of this is based off of me making an assumption. Because what if we were out of ketchup? What if we just decided to change it up and we're not going to have ketchup on our hamburgers today? We wanted to try barbecue sauce or A1 sauce. So anything's possible, but not seeing ketchup on a day that we normally have hamburgers probably means we're not having hamburgers. All right, so today we're going to learn what it means to write an indirect proof. Now, an indirect proof means that I'm going to prove something by contradiction. And I don't have to do it with our typical two-column proof, but instead it's going to be more like a paragraph, something where you make statements. So how do we go about doing that? Well, the first thing you do is you look at the statement that you want to prove, and you want to go ahead and assume the opposite of what it says. So if it says that 1 plus 1 does not equal 3, we're going to assume 1 plus 1 equals 3. That's what we're going to do. Then you're going to use that assumption, and you're going to continue to use logic to come up with statements that would work until you finally reach something that contradicts what you were given to begin with. Then you simply point out what the contradiction is and say your assumption must be false. So look at what this looks like using something we already know. So going back a couple units ago, we're going to look at two lines along with two angles. So we're given that line M is not parallel to line K. Our goal is to prove that angle 1 and angle 2 are not supplementary. So we know that angle 1 and angle 2 are considered same side interior angles or consecutive interior. If those were parallel lines, then angle 1 and angle 2 would be supplementary. So the first thing we're going to do is we're going to assume angle 1 and angle 2 are in fact supplementary. Okay. Once we do that, we can say that by the converse of, I don't want to say this wrong, consecutive interior or same side interior angle theorem. Okay, then line M is parallel to line K. But our given statement says otherwise, so this contradicts the given statement. So our assumption is false. That's what an indirect proof does. It allows us to kind of make an assumption, which I know we don't do often in geometry. We take that prove statement and we assume the opposite of what it says. So it said they weren't supplementary, we said they were. then we find a theorem that works with that, and if those are supplementary, then those lines have to be parallel because those are same side interior angles. That's the theorem that says that. We're using that converse. But that doesn't work with what our given statement says, so it's false. We're going to see another one. So first thing I'm going to do is I'm going to talk to you about two new theorems. One is the triangle longer side theorem. It says that AB is greater than BC. We can see that. This is 8, while this is 5. If that's the case, then the angle that's opposite those sides, okay, so C is opposite the longer side, then its angle measure will be greater than A, which is across from the shorter side. So C has to have a bigger measure than A. Kind of the converse to that is the triangle larger angle theorem. If angle A is greater than angle C, the measure of angle A is greater than the measure of angle C, then the side that's across from angle A, BC, has to be greater than the side across from angle C, AB. So BC is greater than AB. So here we go. We're going to use an indirect proof to work with this particular problem. It says, given that A is greater than angle C, prove that BC is greater than AB. Okay? So, that sounds pretty good. So we're not really necessarily going with this. We would normally just go through and write a proof, but there isn't really any type of theorems to go with this. Let's use an indirect proof. So assume the opposite of what this says. So if BC is not greater than AB, BC has to be less than AB, or BC has to be equal to AB. All right, if BC is less than AB, then angle A is less than angle C, using this longer side theorem. If BC is equal to AB, then angle A is equal to angle C. And when I say that, we're talking about its measure. And that one is by the converse, or no, I'm sorry, it's isosceles triangle definition. Okay? But both of those conclusions contradict the given that the measure of angle A is greater than the measure of angle C. So our assumption is false. Okay? All right, let's go to something that's more math and less proof. All right, so just using what we know about the larger angle theorem and the larger side theorem, what if I give you triangle ABC, A, B, C, and I tell you that A is 48 and C is 110. We can do some math here. That's 158. We know that B has to be 22. So just drawing it helps me see it. It says list the sides from least to greatest. Find your smallest angle, and the side across from it is your smallest side. So it goes AC. Middle angle is A, which is 48. So the side across from it is BC. Largest angle is 110. Side across from it is AB. So the order is AC, BC, AB. That's it. No real math. Just being able to look at the picture. One last thing. Okay. Triangle inequality theorem. the sum of the lengths of any two sides of a triangle is greater than the length of the third side. If you have a triangle, then two of its sides, when I add them together, has to be greater than the third. And this works for all sets of the sides. So AB plus BC has to be greater than AC. AC plus BC has to be greater than AB. AB plus AC has to be greater than BC. So let's test it. You have to be given three sides and decide if it makes a triangle. So 9 plus 11 has to be greater than 15. Well, 20 is greater than 15, so that works. 9 plus 15 has to be greater than 11. Well, 24 is greater than 11, so that works. And 11 plus 15 has to be greater than 9. 26 is greater than 9. That works, so yes, those three sides can make a triangle. Do it again. 24 plus 18 has to be greater than 6. Oh, 42 is definitely greater than 6. 24 plus 6 is greater than 18. 30 is greater than 18, so it looks good. How about 18 plus 6? Is that greater than 24? 24 is not greater than 24. Doesn't work, so those three things cannot be the side of a triangle. What if they just give me 2 and they say, could you find the third side? Well, how do we go about doing that? Because we don't know, are these the longest and the shortest side? Are this the longest and the middle side? Is it the shortest and the middle side? We don't know. So we'll assume that the shortest side is smaller than 18. So that side plus 18 has to be greater than 40. That means that x has to be greater than 22. And then maybe, and that means that it could be, obviously it's bigger than 18, that makes 18 the shortest side. What if 40 and 18 are the two longest sides, and x represents the shortest side? And 58 has to be greater than x, or x has to be less than 58. And what this tells me is that x has to be a number between 22 and 58. So it has to be greater than 22, but smaller than 58. That's it. All right, we did indirect proofs and triangle inequalities. Have a great day.